Hey guys, my name is Tensor. Today we're going to be building a simple microservice with Gokit. Gokit is a bundle of different libraries that you can use for building microservices. These libraries provide components for logging, metrics, tracing, rate limiting, and circuit breaking, and system observability, and resiliency patterns. There are three major components in a Gokit-based application. You have the transport layer, the endpoint layer, and then the service layer. Transports are essentially just the ways that your microservices can communicate with one another and the outside world. In our example, we're going to be building a simple HTTP server which allows us to expose our microservice functions. These microservice functions that get exposed are what are called endpoints. Each of the endpoints represents a single RPC method. And so what we do is we take our methods and we convert them into these endpoints, and then that allows us to expose them to the transport layer. And then the service layer is essentially just the business logic of the microservice itself. Now the example that we're going to be using today is just going to be a very simple user module. We want to be able to insert a user into a database from a web API, and then we want to be able to fetch that user back using a unique user ID that we generate inside of the business logic. Alright, so let's get started by defining the interface of our service. And this is really what you're going to do with most Gokit microservices. So you create an interface with the methods that you want to expose to your transports, and you use that interface to implement your business logic. Here we have a file called service.go inside of a folder called account, and this is where our logic for this microservice will live. And as you can see in the interface, we have two methods. We have a create user method, which takes in context, an email string, and a password string, and it returns a tuple of a string and an error. And then we have another method called getUser, which also takes in the context and an ID string, and then returns a tuple of a string and an error. Now that we have our interface for our service, let's go ahead and create a struct which will represent a user inside of our business logic. Our user struct has an ID string, an email string, and a password string. And because we're going to be serving this through an HTTP API, we need to be able to convert it to and from JSON. And that's why we have these JSON keys here. So ID will be the key ID in our JSON object, and it can be empty, so we put this omit empty key as well. Then email will be email, and password will be password. Now, because we also want to be able to put our users into a database, I'm going to create another interface inside of our user.go file, and this will have functions that are very similar to the ones that we have in our service interface. So we have a create user method. This one takes in the context, and instead of taking in an email and a password string, it just takes in a user struct. And also, rather than returning a string and an error, it just returns an error. The getUser method, on the other hand, will be exactly the same as the other getUser method in that it will take in the context and an ID string and then return a tuple of string and error. So these two methods will help us interface with our database, whereas the other two methods will be the ones that we expose from our microservice. Alright, so now let's go ahead and build the basic business logic for our service. And to do this, we want to implement our service interface on a structure. And we'll create a structure called service with a lowercase s, which will have a repository inside of it and a logger. We'll use the repository so that we can interface with our database, and then we'll use the logger so that we can actually see what's going on inside of our microservice. Now, of course, we're going to need a function that will allow us to create this service, and to create it we just need a repository and a logger. This will output a service interface, and of course we're going to implement our service interface on the service struct. But remember, our service interface has the two methods on it, so this struct does not satisfy that interface just yet. Alright, so we can go ahead and add these two methods into our file, and then we can go ahead and implement them on the service struct. So for create user, we'll take the logger inside of our service and we'll modify it so that we know that we're executing this method. We can call log with, pass in the logger, and then tell it that the method is create user. Then we want to go ahead and take our email and password string and use them to create a user structure. And of course, to do this, we also need to generate an ID. So we can use a library that will allow us to generate a unique user ID. And I'm going to use version 4, so unique user ID dot new version 4. And then we'll get the string from that, so unique user ID string, and we can then pass it into a user struct. And by the way, this is the library that I'm using for the unique user ID, so it's github.com gofrs uuid. Now that we have the user, we can go ahead and call service.repository.createUser, pass in our context and the user, and if we get back an error, we want to log that error with our logger and then return it from this method. This method returns a string and an error, so we need to return an empty string in this case and then return the error itself. Then if we do not get back an error from calling create user on our repository, we want to then log in our logger that we did create a user, and we can log in the actual ID of that user, and then we can return success as the string and then nil as the error. So this method essentially is just a wrapper method around a method that calls to our database. And of course, the method doesn't really care about the logic of the database. All it really knows is that this method here takes in a context and a user. It doesn't really need to know about anything else aside from that. That's important to note because what that means is that we could create multiple backends and repositories. For instance, say we wanted to do like MongoDB and Postgres, or maybe something like Redis. We could use these methods over and over again for multiple different repositories in that sense. Now the getUser method is going to be a little bit more simple than the other one and is going to be very similar. So again, we're going to set up the logger, and we want to set it up with the method of getUser. Then we can call repository getUser, pass in the ID string and the context, and this will give us back an email string and an error if there is one. And if we have the error, we'll log it into our logger, and then we'll return an empty string and the error in the tuple. Otherwise, we'll log that we got the user and then return the email string and nil for the error. Alright, so now we're finished with the logic. We can go ahead and create the repo logic. That is the logic that interfaces with the database. Now, this code is going to follow a very similar pattern to our service code. So we'll create a repository struct, and this time rather than having a repo inside of it and a logger inside of it, it'll have a DB inside of it and a logger inside of it. And we'll use this repo struct to implement the repository interface that we created before. And also we can normalize our errors by creating a custom error up here, which will just say unable to handle repo requests. Now for this application, I'm going to use PostgreSQL. You could use any database type you want, and of course you would have to change the logic accordingly. Let's go ahead and generate our new repository by creating a function called newRepo. So this takes in an SQL DB and the logger, and then it outputs a repository interface, which we're going to implement on this struct. So we return the repo with the DB and the logger inside of it, and then of course we need to add the other two methods, createUser and getUser. So here we have createUser and getUser, and again createUser is going to take in a user and the context, the getUser takes in the context and the ID string. With createUser, we're going to be putting the user into our SQL database, so we need a string of SQL that will allow us to do this. We'll have a table called users, and that table will have a field called ID, email, and password, and we can just use insert into users ID, email, password. The values will be $1, 2, and 3. Before we actually try to execute the SQL though, we need to verify that the user has an email and a password inside of it. So we can check to see if user.email or user.password contain empty strings, and if they do, then we can return our custom error. Otherwise, we'll go ahead and we'll call repo db exec context, and this will allow us to execute our SQL string. So we pass in the context, the SQL string, and then we pass in the user ID, the user email, and the user password. If we get back an error from this, we want to return it. Otherwise, we'll return nil from this method call. Now with getUser, we just want to create an email string variable, and then we want to query our database, and we can just use db query row for this, and we can just pass in some SQL that will select an email from the users table where the ID is equal to the ID that we pass in. And of course we can then scan that result into our email variable. If we get back an error, we'll return a tuple of an empty string and then our custom error. Otherwise, we'll return our email string and nil. And now we more or less have a complete microservice. So this microservice will allow us to put data into a database and fetch data from the database. However, we're missing our transport layer. So we need to tell the service that we want to serve it over HTTP. And one of the best things about Gokit is the fact that we could implement multiple different transports. For instance, if we wanted to talk to other microservices using gRPC, we could implement that along with HTTP, or we could implement it instead of HTTP. We could also implement Thrift, and there are a bunch of other transport protocols that we could use as well. So to implement the transports, we need to take our methods and turn them into what are called endpoints. And to do this, we need to create structs that represent the response and the request from each of our methods. We'll create 4 different structs. 2 for the create user method, and then 2 for the get user method. I mentioned before that each endpoint in Gokit acts like a RPC. These are the request and responses for that RPC. So for create user, we pass in an email and a password, and of course we need to serialize this from JSON. And then as a response, we'll get back a string that will tell us whether or not it succeeded. For the get user request, we want to pass in the ID, and then we'll get back an email string. One thing to keep in mind about these structs is that every single one of them needs to be public. That's why I'm using capital letters for both the struct names and the fields. So make sure you do that, otherwise it will not work properly. Also, because we're using JSON, we've got our JSON keys on each of our values here. If we were using another transport type, we could implement that as well. Now that we have our requests and response structs, we can go ahead and create an endpoint struct. And the endpoint structs contains the methods that we want to expose to the public. We want to expose both create user and get user, and we'll convert them to this endpoint.endpoint type. If you look at the type here, it's just a function that takes in context and a interface, and then it returns an interface and an error tuple. We can go ahead and of course create a function which will allow us to create this endpoint struct, and for this we just need to pass in our service. We're just going to return the endpoint struct, and what we'll do is we'll pass the service into 2 different functions which will take the methods and convert them into these endpoints. So both of these functions will return an endpoint and take in our service. And of course, since our endpoint is a function, we need them to return a function. And we can use these anonymous functions as a sort of wrapper for our existing methods. We take the request interface that's coming into this anonymous function, cast it as a create user request struct, then we can call service.createUser on our context and the request email and password. And then this will either get us an error or the success string, and we can go ahead and pass that success string into our create user response struct, and then also pass back the error in the tuple. The same thing goes for the make get user endpoint function. It takes in the service and then returns an endpoint, and we take the request interface, cast it as a get user request struct, and then we go ahead and call service.getUser on the request ID and the context. And then this gives us back the email and an error, if we have one. And then we can just return the getUser response struct with the email inside of it and the error on the tuple. Alright, so we've got our endpoints now and our request and response structs. Let's go ahead and create the actual server. So we've got a function here called new HTTP server, which takes in the context and our endpoints, and then it outputs an HTTP handler. And then we can take that HTTP handler and just serve it using the Go Net HTTP library. Since we're going to be using JSON, it's appropriate for us to create a piece of middleware to verify that all of our requests and responses will be of JSON type. So we can go ahead and create a function here called common middleware that takes in an HTTP handler and then returns an HTTP handler. So we just return an HTTP handle func, and the function of course will take in the HTTP response writer and then the HTTP request, and then we can just change the header to content type application JSON and then call the next HTTP handler. Now for our server, I'm going to go ahead and use the Gorilla Mux library just because I like how it interfaces with Gokit. And we're also going to be using the Gokit transport HTTP library to allow us to access the HTTP transport. We want to generate a new Gorilla Mux router, and then we can set in our middleware function by calling r.use. Then we can go ahead and set up our methods and endpoints. Here we've got a post method on the user path that takes in our endpoint of create user, and we use HTTP transport new server to convert that endpoint into the appropriate type to go into this method. Now of course we also need two more functions. If you see here, it says that we need a decode request function and an encode response function. And these are essentially just functions that allow us to encode the JSON and decode the JSON. For our get user method, we want to have a get method on the path user followed by the unique user ID that we want to query. And again, we also need to create two functions, one to decode the request and then the other one to encode the response. Let's start with our encode response function. So this will just take in the context, the HTTP response writer and the response interface, and then it will output an error. And we can just say return JSON new encoder to create a new encoder, and then we can encode the response into JSON. And we can use this function for all of our response structs. Now we need to be able to decode our create user request, and remember the create user request will have the email and password inside of it. So this function takes in the context and then the HTTP request, and then it passes back an interface and an error. And we just create our create user request, then create a JSON decoder, decode the request into this variable, and then pass it back. Now we can come back to our server and slot in these functions for this method. But for the getUser method, because we're getting the ID from the path and not from a piece of JSON, we want to create a unique decode function. So we'll call the decode function decode email request, and then we can create it in our request response file. So decode email request takes in the context and then the HTTP request, and again it returns the interface and an error in a tuple. And we can then of course create our getUser request, and then we can use the Gorilla Mux vars helper function to get back a map that will contain all of the variables inside of our path. So we can get the variable by just passing in the key ID, and then we can just put it into our getUser request struct and then just pass that back from our function. And that's it for our service. So let's go ahead and wire all of this together with our main.go file. Alright, so in our main.go file, we want to start by defining the URI that we're going to use to interface with the PostgreSQL database. So we'll call this DB source, and we'll pass in this URI, and This just takes in the username and then the password for Postgres, followed by the actual address, which is just localhost 5432, and then the name of the database. In this case, it'll just be Go Kit example. And we also want to make sure to turn off SSL mode so we can pass in this flag as well. Also note that I'm using a library here called github.com libpq. We're not going to actually call any of the functions in here, but this is what allows us to use the SQL library to interface with PostgreSQL. And if you wanted to use like SQLite or MySQL, for instance, then you'd have to get the ORM for those specific types of databases. Down in the main function, we want to set up our port, and by default the port will be 8080, but we'll allow the user to change it inside of the command line. Then we need to set up our logger, and we can set it up so that it will have a bunch of items inside of it. So it has a timestamp, it has the caller, and it's going to say that it's on the service account, which is our account microservice. And if we had multiple microservices, then we could change the service name depending on which service it was inside of. Then we can go ahead and log an info message that will just say that we started the service. Immediately after, we can call defer and call a log here that just says that the service ended. So this will execute when the Go code exits. We then need to make sure that we open our database properly. So we can just call sql.open on Postgres with our DB URI inside of it. And if we get back an error, then we want to exit from the application. And of course, we'll log this with our logger as well. Now down here we can parse the CLI flag if we get one, and then we can create our context. So we just call context.background, and this creates a non-nil empty context for us, which we can then pass around through our microservice. To create the microservice, we first need to create a repository. So we can just call account.newRepo, pass in our DB and our logger, and then we can create the service itself by passing in the repo and the logger into the call to new service. We then want to set up a Go routine that will look for when a user tries to terminate the application. We can create an errors channel first, and then our Go routine will check to see if there's a SIG termination in the operating system. And if that happens, if like we hit Control-Z for instance, then it will automatically kick back any errors that come about and kick them through the channel. We then need to create our endpoints for our service. So we take our service, pass that into make endpoints, and then that gives us back our endpoint structure. And then we can create another Go routine which will execute our server. So we just say listening on port, and then we put in the port, and then we can go ahead and call new HTTP server on our context with our endpoints inside of it, and then we can just call HTTP listen and serve and pass in the port and the handler, and if we get back an error, it will get piped into our errors channel. And then finally, we want to make sure that we properly drain that errors channel into our logger, so we can just say level error logger log exit and then just pass in the errors. And that's it for our application. So we're completely done with the code. We can drop into our console and now run this, and then we can open up something like Postman to be able to interface with our API. As you can see, when we run our application, we get back from our logger that we're in the service account, and we have our timestamp here, and then the caller is the actual line of code that called this, and then we get back a message that says service started, and then it says it's listening on port 8080. Alright, so now I'm inside of Postman, and I can go ahead and call localhost 8080 user, and I can call post on it and send in a piece of JSON with an email and a password, and this will create a user in our database. So let's go ahead and hit send, and you can see that we get back a piece of JSON that tells us that we were successful. So we get back OK, success, and if we go back to our command line, you can see here it says service account has a timestamp, the caller, so this is in logic.go, and then the method create user, and here is the user ID that was created for this user. Now we can use that unique user ID to call a get method on the same route with that user ID appended to it, and this should return the email address that we just added to our database. And as you can see here, we do in fact get back that piece of JSON. So it gives us the email of test@test.com. Alright guys, well I hope you enjoyed this tutorial. I may do another one to show you how to add more services to an application like this. So let me know if you're interested in seeing something like that. If you like this video, then feel free to subscribe and like. If you have any questions or comments, feel free to leave them in the box below. And if you dislike this video, then by all means downvote it as much as you like. If you want to support the channel, feel free to go check out my Patreon, and I'll see you guys next time.